Hello dear students, welcome back to the NCERT science class of 9th standard. Dear students, we are studying a very second topic, is matter around us pure, where we have studied already, that is the methods of separation of components of mixture. Dear students, total 6 methods we have studied there. That is, in a mixture, the mixture is a homogeneous or heterogeneous that contains the 2 or more components that we have studied, that mix physically or chemically. That separation methods of the components of the mixture that we have studied in the previous class, and also we are going to study the further that method of separation of the components, in which in the very last class that we have studied the separation of the misciable liquid by distillation method that we have studied. That separation of the components of a mixture by distillation method or liquid miscible liquids that we have studied, whose boiling point, the difference of boiling point is more than the 25 Kelvin that we have studied. Next, dear students, today we are going to study the separation of 2 miscible liquids. Miscible liquids, you know that miscible liquids, the liquids which will get mixed, 2 liquids which will get mixed, those liquids are called as the miscible liquids. That first in the previous class that we have studied, acetone and water get mixed, oil and water, these are the examples of immiscible liquids. Acetone and water, the miscible liquids. Here, dear students, we are going to study the separation of 2 miscible liquids whose boiling point difference is below 25 Kelvin. Below 25 Kelvin. In such cases, we are going to take we are going by a method that is fractional distillation method. In the previous class, we have studied the distillation method, where the 2 miscible liquids that we have separate, whose difference of boiling point is more than 25 Kelvin. But here, 2 miscible liquids we have taken, their difference of boiling point is less than the 25 Kelvin. It means if we are going to heat a liquid, all the liquid will be evaporates. Their boiling point, both boiling point is very near. See, 25 Kelvin, not 25 degrees Celsius. 25 Kelvin. 25 Kelvin means at 273 Kelvin is equal to 0 degrees Celsius. Then see, 25 Kelvin, see how much? At 25 Kelvin, if we are going to heat a mild heat, both the mixtures, both the components will be evaporated. In such cases, see, we have to use a special device here, that is fractionating column. Fractionating column that contains the bits of glasses or bits of marbles that we have to use in this column. See what happens, dear students, when we start to rise the mixture. First, both the components will evaporate and that will move through this column. And whichever whose boiling point is mildless, then what happens, dear students? First components will be evaporate through these gaps in between the particle or in between the glass beads. There is a gap is there. Through this gap, what happens? The boiling point is little more, that will be passes, and that will move through this side tube, which is coated by a condenser, through which a ice cold water is moving inside, and next that will be moving out through an outlet. Then due to this cold nature, what happens? Whatever the gas is passed through this fractionating column, that will be collected in a beaker or in a round bottomed flask first. Again, on rising the temperature, the next component, for example, here, suppose here we are having, that is a mixture of air. By this method we can separate, see, the mixture of air or the component of air. See, by the fractionating method, we can separate the component of air. In air, the different number of gases are there: nitrogen, oxygen, carbon dioxide, argon, etc. Number of gases are present in the atmosphere. To separate the different gases from the air, we are going by this method. Oxygen we have to separate, nitrogen we have to separate, argon we have to separate, carbon dioxide we have to separate. See, their boiling point is very mild, very, the difference of boiling point is very less. In such cases, see what happens to dear students. Here, again, the separation of the mixture of the components of air and also the products of petroleum contains the different products. Petroleum contains different products. To separate the components of the petroleum also, we are going by the fractional distillation method. See here what happens to dear students. Here is a homogeneous mixture which contains different gases. See here, oxygen, the boiling point of oxygen is -83 degrees Celsius. See here what happens to dear students, boiling point. See, when we start to rise it, first when we rise, we have compressed the air we have to first, later we will study in here in this column, that is, first air we have to compress, we have to convert it into the liquid state. Then we have to start mild temperature. If we give the mild temperature, first oxygen will be evaporate out. See, the next after this one, here argon they have given. Argon, that is 186 degrees Celsius, -186 degrees Celsius. Then at the nitrogen, see what happens. Nitrogen, that will be evaporate at -196 degrees Celsius. Isn't it? See what happens to dear students. On rising the temperature, see what happens here. The temperature, on rising the temperature, the first nitrogen will evaporate, that will be passes through this fractionating column, that will be collected separately. Then after this one, at -186 degrees Celsius, the argon will be collect separately and nitrogen will be collect separately. Later we will study detail here. I am going to demonstrate you. Simply I am going to clear your doubt. Here what happens to dear students, first we have to take the air and we have to compress it. We have to convert it into the liquid air, then we have to rise the mild temperature. See, by rising the temperature slowly, one by one, the gases will be separated out and passes through the fractionating column, and when they will passes through the condenser, see what happens, that will be converted into the liquid state. That is called as the fractional distillation column, distillation method. Here what happens, fractional distillation column is there. When the liquid that will vaporize, that will passes through the whole maximum number of liquids will be passes through these fractionating columns, and a liquid whose boiling point is more, that will be passes through this fractionating column. Again on rising the temperature, next liquid will be passes, and again rising the temperature, the remaining further gases will be passes through this, or vapor that it passes through this fractionating column. Next, dear students, that is called as the fractional distillation method. Next come to that is the process of separation of the components of air. How the fractional components of the air is going to separate. See, here it is a very complicated process. First we have to, in air is a homogeneous mixture of nitrogen, oxygen, argon, carbon dioxide, etc. Along with that, air contains dust particle, air contains water vapors. At that time, what we have to do, we have to make the air free with the dust and water droplets. Here by using the filtrate, we have to use. Here what happens, from the air, dust and water droplets will remove out completely. The air, total free air, that we have to move through a chamber. Here what happens in this chamber, here the two pistons are there. By applying the pressure, what happens, we have to apply the pressure. We have to apply the pressure here in the chamber. By increasing the pressure and reducing the temperature, air will convert it to the liquid state. We have to increase the pressure and decrease the temperature. On decreasing the temperature and increasing the pressure, what happens, the air will convert it to the liquid state later in the further chambers. See, first we have to compress by applying the pressure. we have to increase the pressure here, and next that pressurized air that will be moved through this tube, side tube, and that will be enter into a column or in a chamber, where what happens, a coiling of pipe is there through which a freezing cold water or ice cold water is passing. Ice cold water we have to pass through this fractionating column. Through this column, first air pressurized, we have applied the pressure. We have to increase the pressure, and here we have reduced the temperature by passing through the coil, by passing the ice cold water through these coils. Next, whatever the gas is here, that will turn to the liquid air, and that you have to pass, that is liquid compressed air. Liquid compressed air that has to pass through a side tube. Again we have to pass through a chamber that contains separators. Separators where a gas, means different components of air will get separated. First here what happens in the separator, it contains the seeds-like particles, where what happens, the carbon dioxide gas will be separated out. Carbon dioxide gas in the form of dry ice, first it will be separated out, because here little warm temperature is there, little more. On rising the mild temperature, carbon dioxide first evaporates out and gets separated in the separate container. The next liquid air again that contains nitrogen, oxygen and argon, that has to pass through a again further column, that is expansion jet. Here air gets expanded, due to which what happens, nitrogen will be collected from the upper chamber, and next argon will be separated out, and by which then remaining, that is nitrogen, will be collected in a beaker in the form of liquid. Next, dear students, after this one, dear students, that we can say here, air is a homogeneous mixture of number of gases. Next, first we have to compress the temperature, that is by increasing the pressure and reducing the temperature. We have to increase the pressure and reduce the temperature up to the minus temperature also. Then by this, see here, oxygen will be compressed at minus 183 degrees Celsius, argon etc. we have to give. Then remaining we will study in the next class. Thank you.